Continuing 5.4 Effects of Volcanoes. Poisonous gases are another volcanic hazard. Emitted gases include water vapor, carbon dioxide, carbon monoxide, sulfur dioxide, hydrogen sulfide, and more. The water, which is steam when hot, can contain hydrogen chloride in tiny glass fragments, which irritates, damages eyes and lungs. Most of the emitted gases, around 90%, are not hazardous, but just water vapor and carbon dioxide. But small amounts of the harmful gases can have disastrous effects, and large amounts of normally pretty harmless carbon dioxide can also be disastrous. Carbon dioxide gas is odorless and heavy, and it can accumulate, suffocating people, which it did at Lake Nyos. Lake Nyos is a crater lake in Cameroon, Africa, which accumulated and then released a cloud of carbon dioxide. The release was triggered by a landslide into the lake. The resultant carbon dioxide cloud traveled 23 kilometers, killed 1,742 people, about 3,000 cattle and other animals. Mitigation systems have since been put into place that include an alarm system and a degassing fountain. Sulfur dioxide can produce acid rain, and the chemicals can contaminate soil and plants and also cause air pollution known as volcanic smog or VOG. Debris and mud flows of volcanic material, also known as lahars, are loose volcanic ash that can become saturated with water, become unstable, and move down volcano. It can occur in the absence of an eruption. The image shows a lahar. Debris flows can be caused by glaciers and ice melted by volcano and mixed with sediment and rock, which is similar to wet concrete and depicted in the image. Mud flows are composed of finer sediment than debris flows. Many populous areas of Pacific Northwest are built on old mud flows, and using the concept of uniformitarianism, the past gives us an idea that it is not unlikely for new flows to occur in these areas in the future. Darn it. Another effect of volcanoes are landslides, which may be triggered outside of an eruption and may affect areas far from their source. If the landslide displaces a large amount of water, they can even cause tsunamis. The image shows an aerial view and a side view of one of the Canary Islands in the Atlantic Ocean, with a currently slow-moving landslide that could start to move fast with a little encouragement from the volcano it sits on. That risk is a risk many of the people of that island are living with. Hopefully, they won't regret it. About 50 to 60 volcanoes erupt each year. In the United States, 2 to 3 volcanoes erupt, mostly in Alaska. Most eruptions are in sparsely populated regions. However, about 500 million people live close to volcanoes. Vulnerable locations include Japan, parts of Mexico, the Philippines, and Indonesia, and several U.S. cities, especially in the Northwest. 5.5 Linkages between volcanoes and other natural hazards. Pause the discussion and take a moment to jot down a few links between volcanoes and other natural hazards. Can you think of at least 4 links? Get creative, but be able to justify your answers using sound geologic reasoning. Here are 4 links: earthquakes, landslides, fire, and climate change. Earthquakes occur as magma forces its way towards the surface, cracking and fracturing the rock already there. Landslides occur as loose material is shaken and heat melts ice that adds weight in the form of water to unstable slopes. When these slopes fail, landslides occur. Fire happens as hot lava ignites forests and other structures. Climate change occurs as massive amounts of ash and greenhouse gases such as carbon dioxide are emitted into the atmosphere. The ash causes a net cooling, while the greenhouse gases cause a net warming. 5.6 Natural service functions of volcanoes. Now pause the discussion to list a few natural service functions. Can you think of at least 5? Can you explain the natural service functions using sound geologic reasoning? Here are 5. Volcanic soils, geothermal power, mineral resources, recreation, and creation of new land. Volcanic soils are soils developed from volcanic materials. It takes a while. How long depends on climate and other factors. But once a soil is developed, the soil is very nutrient rich. Great for agriculture. I love food. Geothermal power can be generated in areas that are hot beneath the surface. In volcanic areas, oftentimes there are hot springs and hot water that is not too deep in the ground that can easily be used to heat buildings directly. This heat can also be used to generate electricity, which can be used for a wide variety of things, even cooling. Mineral resources are associated with igneous intrusions that are often associated with volcanoes. And recreation is another fun benefit from volcanoes. Who doesn't want to go to Hawaii? Who doesn't want to soak in a hot spring or see geysers at Yellowstone? Maybe you don't, but I sure do. Creation of new land is also useful. I'll mention Hawaii again. 5.7 Human interaction with volcanoes. How do we interact with volcano hazards? Do we cause volcanoes? Nope. Humans do not affect the frequency or severity of eruptions. Minimization of loss of life and property damage is the best course of action. 5.8 Minimizing the volcanic hazard. Minimizing the volcanic hazard includes forecasting, volcanic alert or warning, and control of lava flows. Forecasting is difficult because each volcano erupts fairly infrequently. One way to aid eruption forecasting is to monitor seismic activity. Shallow earthquakes and swarms can precede eruption but may not provide enough time for evacuation. This image shows that the number of earthquakes per day drastically increases before an eruption due to magma moving to the near surface through rock, which cracks. Another aid to eruption forecasting is thermal, magnetic, and hydrologic monitoring. Once again, changes in the temperature, local magnetic field, and water are due to a magma body intruding into the near surface. The hot magma changes temperatures of the ground as it heats up surrounding rock, and may even melt glaciers and accumulated snow of volcanic peaks. This is often detected by satellite remote sensing or infrared aerial photography. The magma also melts surrounding rocks and allows iron to be influenced by current magnetic properties of the area, which may have changed since the time when the rocks originally formed. This is usually detected with ground or aerial magnetic surveys showing new magnetic properties. The magma will also heat water and change groundwater chemistry, perhaps with the addition of volatiles or increased dissolution of minerals in hotter water, which is usually detected with groundwater sampling and analysis. Land surface monitoring for growth of bulges or domes also aids in eruption forecasting. These bulges occur as more magma is added. The bulge can subside after an eruption, as it did for the Hawaiian Kilauea volcano, or the bulge can explode, as it did for Mount St. Helens. In both cases, the land deformation indicated an imminent eruption. Changes in gas emissions may also indicate an impending eruption. The change can be the amount of gas emitted and/or the relative quantities of different gases. Gases that are monitored for change include carbon dioxide and sulfur dioxide, as well as others. Geologic history involving the mapping of volcanic rocks and deposits give ideas of types of effects to be expected. What happened in the past is surely possible to happen in the future. Uniformitarianism! In the United States, the Volcanic Alert or Warning System is based on the United States Geological Survey or USGS Alert Notification System. There are ground-based volcano alert levels and aviation-based color code levels, each with 4 levels as seen in the table. For some eruptions, hazard on the ground or in the air will differ and higher alerts or codes will be issued, as aviation codes are most concerned with airborne ash. Ground levels are normal, advisory, watch, and warning. The corresponding aviation color codes are green, yellow, orange, and red. Take a moment to view the volcanic conditions in the table found in your book.